Namaste. Welcome to this channel, Dr.ARM's Chemistry. We were discussing the theories of acids and bases. In this topic, we are presently concerned with this acid-base strain, and by this time we have seen various factors or points which are concerned with this strength of acids and bases. Here, this is the fourth point, that is acidity and basicity. Acidity and basicity of a substance. Here we will see some examples. That is, we know that halogen acid, that is HCl, HBr, HF, HI, etc. And we know their strains. Similarly, we know also various bases such as NH3 or many other substances which are having such as species, or NH2 species, NH species, NH2 minus species, etc. And we have such number of examples. So here we are concerned with the acidity and basicity of binary compounds. It means these are the compounds in which there is at least one hydrogen atom and any other atom. For example, if you see here HF, it has one hydrogen atom and other atom is fluorine. So here we are taking into consideration only those compounds in which there is at least one hydrogen atom. And in that case we are going to see what are their strengths of acids and bases. So in order to see this, we are also taking the help of the Lorry-Bronsted concept, where we are accepting the definition in order to have the transformation of or transfer of hydrogen, means proton, from one species to the other. Means in this case the acids are substances in which hydrogen is transferred to the base. So for this purpose we can generally show the reactions like this. So if we see the reaction here, He, aqueous, it is split into H plus and A minus, which are also aqueous. Or these are also considered in the form of gases. So if we are considering these in the gaseous state, we have to show these are gases like this. So here acidity and proton acidity is also considered numerically to be equivalent to the proton affinity. So proton affinity is very important, and which is also the part of this acid-base behavior. So here generally we assume, as per the Lorry-Bronsted concept, that the weaker acids have less proton affinity and stronger acids have higher proton affinity. This is because the other atom present here is strongly or weakly have a stronger or weaker electronegative. Here F minus is more electronegative. And as we move down the group, here you can see, as we move down the group, the electronegativity decreases. For example, in case of this hydrogen, here HF, then HCl, then HBr, and then HI. So in this way, as we move down the group, the affinity towards proton is found to be, this electronegativity also decreases. And the electron affinity is more, you will find, with the element lying at the top of this group. This is because this is the more electronegative, and electronegativity decreases as we move down the group. Similarly, if we consider along the period, you will find that the electronegativity increases in this way. There is increase in electronegative characters. So this value of the change here in this reaction, if we see the change in enthalpy when it is ionized, this is delta H, and we have shown here delta H values for various binary compounds which are containing hydrogen atom and any other atom. So here the values are plotted in this way, that is 1700 to 1300 kilojoules per mole delta H. So higher the value of delta H, this is the value for dissociation, is enthalpy of dissociation. Here you can see that delta H is enthalpy of dissociation. So here the value of enthalpy of dissociation indicates that binary compound is weaker acid. So that is weakly acid. So you will find that these are weakly acid species. And as you move down the group, the acidity is found to be increasing gradually. Similarly, acidity also increases when we move from left to right along the period. So this trend is observed. Again, if we see that if binary compounds containing such species, that is, we have considered the first period, which are the elements which are present in first period, that is hydrogen. So we have taken here only hydrogen as element, and hydrogen is another species, it is H. In case of second group, you will find the elements carbon, nitrogen and oxygen, and these are the compounds of carbon, nitrogen and hydrogen with hydrogen. So these are lying below this in second period. HF is also member next to oxygen here. So it has lower value of delta H, means compared to these, this is relatively stronger acid. Again, if we go to the third period, you will find that there are SiH4, PH3, which are having relatively stronger acids compared to HFRs. And compared to other lying to the left, these are also stronger acids. So GH4 is lying in the fourth period, and that is also having relatively stronger acid. Again, if we move to the H2S and ASH3, H2S is lying at higher position in the group, AS is lying at the lower position. So H2S is a relatively weaker acid, and this ASH3 is a relatively stronger acid. Again, if you go to H2AC, compared to ASH3, H2AC is stronger acid. And compared to HCl and H2S, HCl is stronger acid because it is next to it and it has dissociation constant weaker than this, compared to this left side compounds. And HI is here shown at having delta H much less than 1300. So compared to all these species, HI is strongest acid. So in this way, you will find the strength of acids in terms of these acidity and basicity factor. So these strengths are expressed here in this way. Then if we see that the strength is also expressed in terms of Ka value, that is dissociation constant values. So when we are considering dissociation constant for acid, it is termed as K and when it is considered for a base, it is called Kb. When the dissociation constant for the acid is, that is Ka is much greater than 1, when this is much greater, K is much greater than 1, it is called a strong acid. You can say this is strong acid. And when this Ka is less than 1, then it is weak acid. So in terms of dissociation constant, we are expressing this acidity in this way. Similarly, we can also explain the basicity for a base, that is Kb. So same trend is observed in terms of this Ka and Kb. So when Kb is much greater than 1, it is strong base. When Kb is much less or less than 1, it is weaker base. We are also taking these terms in terms of pKa values. So when pKa value is less than 0, when pKa is less than 0, then it is strong acid, and when pK is greater than 0, it is weak acid. So in this way, we can differentiate between these acids and bases. Now, if we see some other examples, now you have seen that the traits like this. So along period, the affinity increases from left to right. Along this period, the number of electrons increases in the central atom, that is carbon, nitrogen, oxygen, chlorine, Si, etc. So in that case, the number of electrons are increasing. Similarly, number of electrons are also increasing when we move downward in the group. You will find that along the group, the acidity increases down the group. And along this period, acidity increases from left to right. So these are the specific observations made in this case. Now we will see some additional examples. So here you will find that this, if we take the species, that is H2Se, then H2S, then H2O. So this is the example of species which is shown along the group. So this is heavier species, this is relatively light, and this is lightest. But this is most electron negative species, relatively less electron negative, and relatively again least electron negative species. So electron negativity decreases in this way. So here you will find that the element means, you will find that this H2O is a weak acid. This is a weak acid, and this is strong acid. This is because in case of H2O, the hydrogen bond is stronger, and in this case the hydrogen bond is weaker. Here again the hydrogen bond, that is HSE, is weakest, and therefore it is the strongest acid in these three elements. So the electronegativity, as we have seen here, most electronegative, less electro, and least electronegative elements. If we take their conjugate bases, so we can show this order of strength of the acid in this. Now if you take the bases, so these are acids. Now if we take the bases, so we can have this SCH minus, then this is SH minus, and this is OH minus. So in this case, you will find that the strength of the base, shows that or we can say the H2O is relatively a weaker acid. H means as it has seen here. So OH minus is stronger base, SH minus is relatively weaker base, and ACH minus is least means weakest base, we can say. So strength of the hydrogen bond is weaker here. So we have seen also in the above case, that is about the strength of the acids. Then attraction for bond is also we have discussed, that is H2. This HHC bond is weakest than SH minus bond, than OH minus. So this is strongest hydrogen bond, and therefore it is strongest base. Then we will see that, so there are such number of other examples. Now if we see the distribution of charge on the species, so if we take that the species such as NH2 minus, then if we take another species, or in this species you will find that it has one negative charge and two lone pairs. So minus one charge is distributed among two lone pairs. Therefore, each lone pair carries minus 1/2 charge. Therefore, each lone pair carries minus 1/2 charge. Then, if we take another example, that is OH minus. Then, if we take another example, that is OH minus. So this OH minus has one negative charge, and there are three lone pairs. There are three lone pairs. So you can see minus one charge is distributed, or you can say divided into three lone pairs. Three lone pairs, and therefore each lone pair carries minus 1/3 charge. Minus 1/3 charge. Similarly, if you see the another example, that is HF minus. So this has also minus one charge. So minus one charge, and it has four lone pairs. So minus one charge is divided per pair. There is minus 1/4 charge. So in this way, charge is distributed here. So in this way, we can consider other aspects whenever it is required. So with this, we will stop our discussion, and then we will see the next lecture. Next point regarding the strength of the acid-base strength, and this is inductive effect. So till then, see you next time. Goodbye. Please subscribe to this channel and press bell icon and like button. So thank you very much for watching this channel.